Alright, so this will be an instructional video on how to put the Eye of Agamotto kit together. All I've done off camera is install the shafts. I do this by just reaming out the holes with a hand reamer and a pin vise, and then press fitting them in. They should go in relatively easily. A good test to see if you've done it correctly is that the gears obviously should go on, but they should also spin fairly freely and have very little backlash or any sort of wobble to them. If they're super wobbly, or if the pins don't really seem to fit properly, or if they're tilted in any sort of funny way, you kind of have to start over. There's kind of no hope of it working. Additionally, a lot of the parts, I love using any sort of wax lubricant. White Lightning is my favorite, but this allows the parts to interface and have very little friction between them. The entire assembly relies on as many of the components as possible having very little friction. So it's important in the beginning of the process to kind of systematically test all of the parts and make sure that none of them have a lot of friction. With that being said, I guess one other thing that did take a decent amount of time is sanding. There's a lot of surfaces. I think I went over most of them in my readout, the Word doc that I've been working on. That should kind of tell you what surfaces to expect to make critical fits, essentially. So with all of that being said, let's start assembling it. Good starting point is the central piece. So you're going to want to take both of the eye pieces. They fit together like this, and then they go on here. The shafts then get installed like this and like that. Easy. And then this little tiny elastic band gets put over these horns. And what that does is it just kind of gives these a centering, allows them to close. Next part is this eye bezel. The way this works is that there's these two little arms that stick out on the eye, and those sit in here and kind of run up a ramp. There's a ramp in there. And while this is spinning, it opens up the eye for you. So for this part, this goes in here, this guy goes over it, and then these get screwed together with small screws. These should be fairly snug. This part you can test. It basically just opens the eye. Nothing fancy. So once the parts here are nice and tight and in place, you want to put this in here. The orientation doesn't really matter. We're going to work on that later. But what does matter is that it has very little friction. I'm going to be saying that a lot during this assembly, but it's super critical. So the thing that holds this and stops it from coming out is this gear. This gear has a small pin on it. I don't know if you can see that, but there's a pin right there. This pin fits in a slot. This slot stops the gear from rotating more than 180 degrees. This is to help kind of manage how much motion there is in the assembly itself. So this is a little, not tricky, but it's just a thing that you have to think about. What you want to do for this step is orient it. I like thinking about it this way, partially because this is how I designed it. But I have the servo on the right side. I want the tips of these guys basically to line up. And what this means is that, or basically the eye bezel is going to rotate clockwise. So what that means is that I need the bottom of the pin to be in its most anti-clockwise direction. So if you can imagine that this wants to spin clockwise, and on the bottom I have the gear, and I'm pushing that all the way to its most anti-clockwise position. So if you do that, you'll feel it bottom out on that pin. And then at that point, what you want to do is flip the assembly over, and you'll see that these guys line up. So the holes line up. So again, very little friction in it. Each component that you add is going to add a little bit of friction. If you find that you've added too much, you can usually back off the screws ever so slightly, and that gives you a little bit more freedom. It's very important to check that constantly throughout this process. You can see that the eye, mechanism still works fine. At this point, it might make sense to install the eye. We can choose kind of what orientation we want later, but for right now, it is important that we get the electronics. So all I've done off camera is kind of soldered on some standard jumper leads and then hot glued them as strain relief. So, next step, these guys, they move super freely. This is what you want to see. Additionally, you want the whole thing to move super freely. Again, if any of this feels like not super buttery smooth, where you can move it with one finger, go back. You have to sand it. You gotta, scrape the parts, use white lightning. If it's not smooth, it's not going to work at all. So here, I've oriented it, I guess, in the New York setting. This is kind of how it is in the movie. The servo is going to go in. What I've done is I've notched here. I've put a little notch in it. I find that helps. I like having the wires kind of come through the bottom. So what this allows me to do is if I hold them appropriately, I can scooch one side in. What works best. So if when you first do it, you just don't even think about the wires. And let them kind of fall into place. And this guy, you just kind of snap past that. Now I have the wires. Take this camera for 1 second. So now the wires are free to come through right there. I'll install that. All right, so we have the wires here. You can pull these until they're kind of tight. All right, I have both wires kind of going in the same direction. All right, so let's see. Now these gears. So the way these gears work is that there's this standard, these are all standard gears. This one has the bottom cutaway, and that engages only the top ring. Like that. Then this guy engages that one. This guy, again, just only touches the top one. And then this one comes in through the bottom and touches the bottom one and this one. So that when you turn both of them, all the gears move. So this one goes in later. At this point, what you want to do, without this one in, when you put this one in, it locks them all together, and then you can't turn one without the other. If you pull this one out, they turn, or they are capable of turning independently of one another, like that. So you want to make sure that they are in the correct orientation. I believe from the movie this is the New York, New York hub setting or whatever you want to call it. So everything is in. I've got some posts in here. I also reamed those to the appropriate size. You want to just put this on and then install it with some long screws. And this is one that is difficult to, or not difficult to install, but it is one that you can over tighten. So take note of how it feels before you screw this together, and then test it again once you put the screws in. And you may end up having to back off the screws just a little bit to minimize how much friction you've added. Snug all of them down. And then test. So I can tell right now, just by twisting this, that I've added a lot of friction to that. So I want to come back and just like quarter turn everything back a little bit. And that has way less friction to it. So I think that'll be maybe a little bit more. See if that helps. That's way more likely to work. So again, just make sure everything's aligned. Put that together. Put this together. That's pretty much it. At this point, it might make sense to think about gluing stuff in. For one, I think I'm going to do that. Let's see if it's done. Yeah, it looks pretty good. All right. So then this guy can go. What I'm trying to do is line these up so that I can put this in without ruining it. So what I'll do is off camera, I'll just cut this out real quick. All right, nice and clean, looks good. So now, last few steps. This guy, we are going to want to make sure that everything lines up, which it appears to. No issues there. So let us glue this guy in a similar position. And this is just to ensure that nothing binds or crunches or makes unpleasant noises, or standard gear stuff. All right, call that good enough. So now these guys will align with this. They will come out here. And I should still be able to put on some form of lanyard. So those go in there. This goes in here. Something like that. This part, you want to just align stuff. It's not very easy to show on camera, but essentially what I'm doing, take this apart real quick. Essentially what I'm doing is I'm looking at this post and making sure it goes, looking at this post and making sure it goes in this hole. If you do that, everything else should line up accordingly. So this is a tricky bit, but nothing that can't be handled. So here we go. This guy goes in there, this guy goes in there. All right, so I carved this out a little bit more. I think there'll be more room for it. Trying hard not to crush these parts. So this guy goes in here like this. This guy, doesn't matter. These are the same compound gear, so it does not matter which one goes where. That is probably something worth noting. That goes there. this goes here. And the hope is that it all goes together. Hey. So those go in, no problems. Now, one thing actually that I did not do, but I'm pretty sure is fine, is make sure that it's facing the right way. One thing that can happen during assembly is that this can get twisted around, and you don't want that to happen. You want to, before you put the back on, make sure that it is facing the correct direction. I am not, because I have no regard for videos. I'm fairly confident that it's fine. So I'm using 4 long screws in the 4 remaining holes. And then 2 short screws in the center holes. Alright, so as a final test, what hopefully we can do is I've prepared a rat's nest of wires to put them together, and hopefully everything will work. Failure, as Adam Savage would say, is always, always an option. I found that the servo needs more than 5 volts. Ideally, I would have had it powered with something less substantial. A 5 volt would have been preferred, but I find that it really needs like 6 or 7 volts at the servo in order to rotate the assembly, even when you're super careful. If you guys want to be even more careful than I have and get it working with 5, I applaud you. But at this point, using a 9 volt battery with a little power, DC power converter, this steps it down to, I think, 7. That's easier. So. So I don't know what that was. I had to break through something, but looks like the LED is not working. Let's see. I think that is all I have to show. I don't put this on until it's completely done, but the rest of it is kind of fiddly and not really worth showing on camera. So I'll sign off for now. It works. All that's left to do is really troubleshoot why the LED doesn't work. But that's more of an electronics project than a mechanical design project. So I won't bore you with my inadequacy in all things electronics. Signing off for now. See you next time. Bye.